Good. Okay, all that is off. And you can only hear one of me, right? I've not got two microphones on by accident. Okay, it's
Okay. So welcome, Jason, first of all. And I'm really super excited to be with you today. And I'm really appreciate for your time because you know that today is the Google I/O day, actually. And
great. Yeah, perfect
yeah,
timing too.
yeah, you should be really busy. And I guess, meanwhile, I'm touching that in the Google I/O website, there is some Q&A button. And if you have some questions about TensorFlow.js, we can directly ask you, right?
Yeah. I think they should come through to me at some point. And if not, you can always find me on Twitter. I'm at Jason_Mays on Twitter or
Mhm.
LinkedIn. Just search my name there as well. And I'm happy to answer things offline for anyone who's watching this later on. That's completely fine.
Thank
So,
you.
yeah.
Thank you. I'm shooting this video for my big data processing courses at the Sabancı University. And I think this Q&A is really good opportunity for the introduced in TensorFlow.js and meet the TensorFlow.js. So before the starting Q&A, could you please introduce yourself?
Yes, of course. So I'm Jason Mays. I'm the developer relations engineer for TensorFlow.js here at Google. And essentially what that means is that if you're using machine learning in JavaScript somewhere out there in the world, you'll probably bump into me at some point. I've also made a lot of courses on edX and other places like this where you can go from zero to hero, learning about WebML to get superpowers in your web apps and many demos and things like that. So yeah, if you search TensorFlow.js online, use the hashtag made with TFJS, and you'll find all the things our team has been creating. And yeah, I'm happy to talk more about that.
Yeah, you're been working at the Google for 11 years, right?
That's correct. It's gone very fast. I
Yeah.
actually started as a web engineer, and then I moved into creative engineering, which was exploring emerging technologies. And that's where I actually discovered machine learning. And then I realized I wanted to combine the two together because I really enjoyed my web engineering background, but I knew that machine learning was also all of our futures at the same time. So I
Yeah.
wanted to combine the two. And it just so happened a couple of years ago, TensorFlow.js was looking for someone from a web engineering background who's passionate about machine learning. So that kind of fit my criteria perfectly. And here I now am representing them. So it's been a fun journey.
Yeah, I spoke with you from LinkedIn, and I got some from information from, about you. So thank you for introducing yourself.
Cool. Yeah.
So I think there may be my classmates who haven't heard or who haven't familiar with the TensorFlow.js, and not only, of course, my classmates, but also most people who know the TensorFlow.
Yes.
Uh, in general, don't know really much about the TensorFlow.js. So I think that's a really good opportunity for us to make some Q&A with you. So
Yeah.
thank you for your time again. So let me start as fast as possible because we have limited time.
That's fine.
And
Yeah.
so can you describe the TensorFlow.js to us, and what does TensorFlow.js do?
Yeah, that's a great question. And essentially, some of you might be familiar with TensorFlow Python, for example. And TensorFlow is Google's machine learning library. It's open source and allows you, you can think of it like the building blocks, like Lego building blocks that you can use to make any machine learning model that you might try and invent. And TensorFlow.js is exactly the same thing, but written in JavaScript. And given that 70% of the world use JavaScript in professional development, as a huge number of developers that typically couldn't use machine learning before, who now can. And of course, JavaScript is one of the few languages in the world that can run in many different locations. So on the front end in a web browser, but also server side in the cloud. And even on a Raspberry Pi Internet of Things device, you can run Node on that. Therefore, you can also run TensorFlow.js there too. So it's very flexible. And if you are already using JavaScript, then you can use our models in any of those locations with ease, basically.
Mhm. Can we really need to Python to use the TensorFlow.js?
No, so you don't need to use Python to use TensorFlow.js. You can be a pure JS developer and never touch Python if you want. You can build models from zero in JavaScript, all in the browser. Obviously, if you want faster training, it's probably best to do that on a cloud server. But for that, you can use Node.js, which is also JavaScript essentially, and you can then train faster on a more dedicated graphics card in the cloud if you wanted to. just like you can do in Python, but in JavaScript. So yes, you don't need to use Python to use TensorFlow.js. However, if you do know Python, you can actually take models from the Python world that you've already maybe created and convert them to TensorFlow.js using our command line converter on Linux on the server side. So if you do prefer to stay in the Python side to make the models, you can then deploy your models and reach more people with TensorFlow.js by having it running in the browser later on. Yeah.
So another question that I want to ask you, all of this process training, deployment is really consumes to memory. Actually, how does the TensorFlow.js provide acceleration? Because this process is really depends on our limitations of hardware, right? So
Sure. Yeah.
How can you handle?
Yeah, very good question. So I guess there's two answers to this question. If you're using us on the server side, then it's exactly the same problems as the Python world. Like it depends on the size of your server, your graphics card, your RAM, but you'll know those in advance what those limitations are because you know what server you've hired from the cloud. Now, when you're running on the client side in the browser, you don't know what device you're going to be running on. It could be a cutting edge desktop machine like my home built computer I've got right here, or it could be a 5-year-old laptop, or maybe even a mobile device like a smartphone. And of course, smartphones have very limited amounts of RAM and even graphics processing power these days. So especially if it's 5 years old or something like this. So in those situations, you have to be mindful of that. If you're trying to train things in the browser, I would stick to lighter models that are suitable for transfer learning in a fast manner. So things like MobileNet, that kind of thing. You can retrain that even on a mobile phone with TensorFlow.js quite fast, in fact, with transfer learning. And there's a great website called teachablemachine.withgoogle.com. And in fact, maybe I can actually just share my screen and show you that in action to give you an idea of how fast things can actually work in a browser. So let me go ahead here and open up a new window. Just give me a moment. Let's see here. Open new window. I'm just going to share my screen. Teachable machine. And let's see here. Share a tab. Teachable machine. All right. So hopefully you can now see my browser window. Yeah, all good?
Yes.
Is it fitting on the screen correctly on your side, or is it looking funny?
Yeah, it's really good.
Hang on. Let me just reshare that screen. I think something. Oh, hang on one moment. I've got a little issue with my screen share here. Sorry, 1 second. Teachable machine. There we go. Okay, now you should see it perfectly. Okay, good. So this is the Teachable Machine website, and it's powered by TensorFlow.js. So if I click on Get Started here, you can see there's many different types of projects you can create, and you don't even need to be a machine learning expert to use these, in fact. So if I click on Image Project, I'm just going to train a standard image model. I can see here we've got 2 classes on the left-hand side. You can actually add more classes if you like. However, I'm just going to start with 2 just to kind of show you an example. So the first thing I'm going to recognize is maybe my hands. I'm going to show my hand to the camera. And the second thing I'm going to recognize is Jason, which is just my body. And if I enable the webcam for the hand class, you can now see a live preview of the webcam over here. And what I'm going to do is I'm going to hold my hand up to the webcam and just gather some training data. And you can see here, I've gathered like 38 examples of my hand and I moved it around the screen to get some variations. And now I'm going to do the same thing without my hand, just my body. And here I am moving around a little bit and getting roughly the same number of images. So 43 and 38, that's close enough. I can then hit train model. And now live in the browser, there's no server involved here. In TensorFlow.js in JavaScript, we're going to retrain the MobileNet model to learn from what it's learned in the past to then classify these new objects. And now you can see in under 10 seconds, already trained a new model for us, and it's giving a prediction of Jason with 100%. If I move my hand into shot, you can see it changes the hand of 100% too. So Jason hands. And that's how easy TensorFlow.js can be to use when you integrate it into a website like this. Now, of course, this model is not going to be very robust. You need more training data to be more robust. But if it was good enough for your needs for a prototype, you can click on export here and you can download the model and then host it on your own website, add your own user interface, and you've got a hand classifier very quickly, for example, to kind of show some prototype to someone who might be interested in that. So that's basically how easy it is to do transfer learning in the browser for simple models like MobileNet. Obviously, larger models that are more complex, or if you're trying to train a model from scratch, especially if it's like something like a convolutional neural network, you probably want to do that in Node.js and then take the resulting model and run that in the browser for inference. That will be still, but the active training can be slow for those larger models if you're doing it from scratch. But yeah, hopefully it gives you a flavor of what's possible. Yeah.
So that means we can do training in addition to the inference, right?
Correct. Yes, you can do training and inference in TensorFlow.js.
Wow.
If you're doing that training in the browser, it can be slower if it's not transferring, if you're doing from zero. So I recommend using Node.js for larger data sets and more complex models. And then the resulting model, you can still then run in the browser very fast. It's just the active training that can take more resources.
Well, I didn't know.
TensorFlow.js is optimized for inference in the browser. But you can do training as well if you want to, as you just saw. So yeah.
So yeah, thank you. I didn't know. Good to know for me. So we know that TensorFlow.js has many APIs and backend platforms. So can you briefly tell us about them?
Yeah, that's a great question as well. So where do I start here? So essentially, there's different. So by backends in TensorFlow.js, we're actually referring to the hardware you're executing on in the browser. So in the web browser on the front end, you've got plain old JavaScript, which is the slowest form of execution. That's just vanilla JavaScript, doing the maths in that. You then have WebGL, which is a graphics programming language that leverages the GPU. And it turns out that some very smart folk on the TensorFlow.js team realized they can actually use computer graphics to do mathematics. And of course, machine learning is just a bunch of mathematics.
Yeah.
So we figured out how to represent those machine learning things as textures in the graphics card to do mathematical calculations. So that means we can actually leverage WebGL as one of our backends to get much faster performance in the browser. And some of our latest models, such as pose estimation or body segmentation, for example, can run at like 120 frames per second on a fairly old graphics card. In fact, like a 1070 GPU from NVIDIA, you can get like 120 frames per second out of that, which is pretty impressive. We've also got WebAssembly, which allows you to leverage the CPU in a more advanced way. And some of our smaller models can leverage that to go very fast as well, also in the hundreds of frames per second, as that has actually been improved significantly over the past few years. And looking towards the future, we just announced at I/O this year a new backend called WebGPU, which is specifically targeting at getting much more lower level connectivity to the graphics card and a much faster performance. And we've shown that the web GPU backend is still in alpha right now. You have to enable a Chrome flag to enable it in the browser. But if you do try it out, we've seen 2 to 3 times better performance in web GPU for some models in the browser. And bear in mind, some of these models are already running at 60 plus frames per second. So that's really incredible. And we're very excited about that for the future. And then very quickly on the server side, we've also got Node.js as a backend, which actually leverages the same backend as Python. So both Python and Node.js on the server side actually talk to C++ behind the scenes. And they're just wrappers around that C++ API that uses NVIDIA's CUDA and other things to get acceleration. So Node.js is the same as Python on the backend, no difference, it's just a wrapper around the C++. It's only the front end that has different backends to what you might be familiar with. So yeah.
So while we are talking about the new features of the TensorFlow.js, so could you please mention some new features and new improvements to TensorFlow.js for the Google iOS 20?
Yeah, definitely. Obviously, to get all the features, do check out my talk on Google I/O. So if you go to the TensorFlow YouTube channel, you'll find my 2022 talk for TensorFlow.js, the nice overview.
I saw the post on your LinkedIn.
Yes.
Google I/O TensorFlow.js monthly, right?
Yes, I have my blog there too. That's correct. Yep. So some of those things I teased in that newsletter. But yeah, for an overview for people watching right now, we've announced a brand new model that's able to do depth estimation for human body. And what that's really cool, because if you can, for every pixel in the image, understand how far away it is from the webcam, you can do some pretty cool things. And one of the examples we've done is image relighting. So I can cast like rays of light around me in real time, and you can kind of see that in a very realistic way, because it knows how to like kind of go around my body. Or I can even take a single photo and make it 3D, like you might have seen on Facebook. But you can do this all in the browser now natively without having to pre-process all that on the server side. And actually, maybe I can find my demo just to show people right now. Let me see if I've got it on my Twitter to hand quickly. 1 second. Let me see here. Profile. Let's see if I can share my screen here. Where's my I did post this recently. Oh, here it is. Okay, so let me open this up and then share my tab again. Share a tab, and I think that's the one. So this is going to take a moment to load as I'm sharing my screen at the same time. But once it does, is it going to come? There we go. All right. So basically, if I just make the intensity a little bit higher, so you can see, if I am standing in front of this, I can move this light source around. You can see how it's going around my body.
Wow.
And I can move around, and it kind of like, it kind of interacts with this kind of virtual sun, if you will. And that's only possible because we're using the new model that we've produced to estimate depth for my body. It knows where my face is versus other parts of my shoulders and things in relation to the camera, and we can then cast these like light rays around me in a kind of somewhat realistic way. Now, the other thing I want to quickly share with you is another model that we improved recently. Let me find it. Here we go. Yes.
Adjustments is really hard to do it by manually. So I really surprised that.
So the adjustments for,
Yeah, for example, the light is coming from. If you want to do this manually, it's really hard to do
yeah, it
this.
can be very tricky to do if you don't have this depth map information. You
Yes.
kind of need that to do things realistically and efficiently as well. So yeah, we're hoping this model will be used by people in new ways that we've not seen before as well. That's just one example, of course, but there's many others that are pretty cool as well. And if I just quickly try and find one other demo here that I want to share with you, let's see if it's, where's it got? Aha, here it is. So we've also got, share my screen, share a tab.
We cannot see now.
It's coming now. There we go. So this is the portrait depth API that I was just speaking about. But you can see here how we're also able to make these 3D photos come to life using the same technique. And essentially you get this depth map coming back here that you can see this lady. This is the input image. You segment her body from that, and then you pass that through the model, and you get this kind of depth map that estimates which parts of that face are closer to the camera versus further away. And you can use that to then create the effects that you just saw. So we're very excited to see this in action here. So if I go to this demo here, you can see it actually live in action. I can try different faces here, and it will basically regenerate them. And there I am. And you can see the depth map come back in real time, and then the 3D effect that you're able to generate there on the right. So do feel free to go and give it a play. If you check out blog.tensorflow.org/JS, I believe you can find the TensorFlow.js blog posts and try it for yourself. And then one other model I want to quickly share with you is our updated TensorFlow.js face mesh model, which you can see running here in the browser right now. And you can see this is running, even though I'm sharing my screen with you, so it's using my GPU power, it's still running at 80 frames per second, which is incredible.
Wow.
Without this, it can run over in the hundreds when I'm not sharing my screen at the same time. But you can see I can move my face really fast, and it's able to capture that without any problems. And I can open and close my mouth. I can see it's getting all that data. So we're starting to see people take this and use it for some really exciting stuff. There's a company called Hallpass that are taking this kind of facial geometry and combining it with their own custom TensorFlow.js models to then do facial animations on characters in the virtual world and that kind of stuff. With all this metaverse stuff getting very popular, people are looking for ways to control those characters with their real face. And TensorFlow.js might actually provide a solution there for some people. So exciting times ahead.
Yeah, it's really like I will send my samples for you.
Excellent.
Is there any question that I got? What are the machine learning methods you use most often when training your model?
For learning machine learning?
Yeah.
I guess I'm fortunate enough to like ask all of my managers and people at Google who literally wrote TensorFlow lots of silly questions. And, I try and, from my learning of all of this, try and produce courses that can help everyone else. So I recently launched an edX course, which basically covers from zero understanding of machine learning. So it assumes no knowledge of machine learning to take you to becoming quite productive with machine learning in JavaScript in the browser. And that's free for everyone to take. And I'd encourage people to check that out. It's available on edX.org, and just search TensorFlow.js. You'll find it there. Alternatively, if you prefer a book, there's a great book by Gartner Board, who's one of our Google developer experts, who wrote an O'Reilly book for TensorFlow.js. I think it's called Learning TensorFlow.js or something like this. And check out that book if you prefer reading a physical book rather than an online course. And that's also a very good resource to give you the 101. And then there's also a book by Manning Productions that was written by the TensorFlow.js team, the original TensorFlow.js team who created TensorFlow.js, and is more advanced, but it tries to go from the beginning, but you probably want to read Grant's book first or take my course first before you dive into that book. But if you do want to go further after that, that's going to cover how to do more advanced models in JavaScript, like LSTMs, GANs, and all this kind of stuff as well. So more advanced stuff. Yeah.
I will add at the end of the presentation these related links of the course.
Yeah, perfect. Yeah, feel free to add those in, and yeah, perfect, lovely.
So my question is that what are the operations that are not yet supported in the TensorFlow.js?
That's a good question. I mean,
or is there any?
It's quite a bit. Is like most models do convert these days, actually. But if you're using Python and you're trying to just take a Python stack and convert it to JS, if you're doing a lot of pre and processing or using special layers,
right? We can convert the TensorFlow to TensorFlow.js.
Correct. Yeah, we've got a converter in on the Linux command line. You can just use it. You take the saves model from Python, and then out pops a model.json that's suitable for the browser. However, if you're using advanced pre-processing layers or post-processing layers that are part of, say, the Keras API, we don't necessarily support those specific layers sometimes. So some of those won't convert yet. And you have to use the actual, well, replicate the pre and post processing in JavaScript instead. However, if you do replicate that in JavaScript, you can actually sometimes run faster than Python because of a just-in-time compiler of JavaScript. And we actually saw a good case study with Hugging Face, who converted a model called Distilbert into Node.js. And they had to rewrite their pre and post processing layers for the same reasons I just mentioned. However, because they did that, it was 2 times faster than the Python equivalent. And we also just released a case study of LinkedIn, who used TensorFlow.js for web page optimization in real time for billions of users around the world on LinkedIn Lite. And they also saw a performance boost by using TensorFlow.js in Node over their Python version of the model. So if performance is top of mind, even though it might be a bit more work to rewrite some of these layers in Node.js because maybe you don't have NumPy, you're going to use some other library in JavaScript to do that, it might still be worth it. It might be worth your time to start building up your stack in JS to get that speed boost.
Yeah, thank you. And the last question is that from my friends, and he said that the size of the machine learning models are getting bigger, and are there any recommended best practices to improve the user experience when using these large models in the browser, like the caching or etc.?
That's a really interesting question as well. It very much depends on your end users. So if your end users are, say, researchers, they've got really good Wi-Fi and they're on a desktop computer, they can download the model once and then it's all cached locally. Then you can still put down 100 megabyte model file and it will work just fine in the browser. In fact, we converted the BERT model and it's like 100 megabytes and it runs just fine. It's actually pretty efficient, even though it's very large. But yeah, if you're maybe in the middle of a field on a mobile phone and you need to use it on the go there and you're not able to cache it in advance, then maybe that's not the best user experience for those users, right? So it does depend on what your user is trying to do and where they're located and their network conditions and this kind of stuff. However, web apps can work offline. So if they're able to cache the model and save to something called local storage. In fact, in TensorFlow.js, there's a API called model.save, and you can actually save the model so it works offline once it's been loaded once. If you're able to do that, then that could be a great solution for larger models. If you're not able to do that and you still want to be able to use larger models, maybe they're gigabytes in size, then you can run it in Node.js on the server side and maybe use WebSockets to stream the results back to the client side in somewhat real time. And that could be a good compromise as well. So similar to what you might do in Python, but in Node. And with WebSockets, it makes it super easy. There's a library called socket.io, and it's really easy to use. And in a few lines of code, you can just send data bidirectionally in real time with very low latency, which could be very good for real-time-ish applications. Yeah.
So I'm done. Thank you
Cool.
for your time again, Jason. It's really good opportunity introduced to TensorFlow.js, and I'm really glad to showing your examples and your live samples, and thank you again.
No problems. Yeah, thank you for inviting me on the show. And yeah, if anyone's got questions, please connect with me on LinkedIn or Twitter. Happy to answer them offline as well. And good luck with your TensorFlow.js adventures. Yeah.
Thank you.
Cool. I shall hit stop.
Yeah.